Hi guys, today just want to show the video how to find the complex zeros with factoring technique, and also with that the rational zero theorem. So let's start with the first examples. So p of x is x to the power of 3 minus 3x squared plus x minus 3. So this one is a cubic quadrinomial, so we try to factor by grouping. So we try to factor by grouping, so we try to group the first two terms together and then the last two terms together. So we take out the greatest common factor and we got x squared. And then the second group, the greatest common factor, it's only 1. And then you see the common binomial, so it's x minus 3, so we pull that out, and then we got x squared plus 1. And as you may notice that this one is non-factorable, so we just want to set it equal to 0 separately, and then we solve for x. So x squared equals -1, so x equals plus minus I. And then for x minus 3, so we just set that equal to 0 as well, so we got x equals 3. So we got 1, 2, 3, 3 solution sets. And then once you put it back to the complete factorization form, so we just put in x minus I, x plus I, and then x minus 3, so that's p of x. And here's another example. So we do have 1, 2, 3, 4, 5. It's a 4-degree pentanomial, so find all the zero first. So this one is non-factorable, so how do we find the zero? So we use the rational zero theorem. So we list the constant term, we got negative positive 26 over plus minus 1. So list all the possible factor of 26, we got plus minus 1, plus minus 2, plus minus 13, and then plus minus 26. And then we try to use the synthetic divisions to find out which one is going to be the real divisor. So try 1 first, you'll see that 1 times 1, then that'll be 1 plus -3, -2 times 1, then we got -2. And then plus 7, we got 5, 5 times 1, we got 5. 21 plus 5, 26 times 1, so bingo, so that's going to be 0 for the remainder. So that means for the quotient we got 1x to the power of 3, -2x squared, and then plus 5x plus 26. And then going through that, the synthetic division again, so this time we try -2 and see what happened. So for -2 we find out that the final remainder is also 0, so that means it's going to be part of the zeros as well for -2. And then for the rest of the quotient, we got x squared minus 4x plus 13. And which is non-factorable. If that's non-factorable, we're using the quadratic formula, which is -b plus minus square root of b squared minus 4ac all over 2a. And then by plugging the numbers, so here's what we find out. So we got 4 plus minus 6i all over 2. So we got 2 plus minus 3i. And then, so the solution we have for the divisor, we got 1, -2, and the one found from the quadratic formula. So we got 2 plus 3i, 2 minus 3i. And then rewrite it with the complete factorization form. Again, you start with the minus, 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 all minuses. So here's what we got. And here's another example you want to try. So again, it's non-factorable, so you want to use the p over q to find out the possible zeros. And then we test them out with the synthetic division. So eventually, so here's what you come up with this. -2, 1 plus I, 1 minus I. And then put this all together, so we got x plus 2, x minus 1 minus I, and then x minus 1 plus I. Okay, so thank you for watching the video today.